Okay, the next thing we want to do is use our library of parts that is provided by SolidWorks to put a pin in this a hole here, so we can pin these two pieces together and they'll turn in conjunction with each other, or in this case not turn. So the first thing we want to do is we want to come over here to the left, to the right, under Design Library. Click that. Now, if the Design Library hasn't been put in, it will say that it needs to install a toolbox right in this area right here or down here. And you simply click on that and it will add your toolbox in there. And now if we go to Design Library, we have some different components here, but we really don't need to be there. We need to be in the toolbox. So if we double click the toolbox, oh, there it is. Click on it, and now I need to add it. And it'll take a minute here. It'll add it. Okay, and now note it's got the plus up here, so we could expand that out. And we can either look at it from here or over in this area right here. Well, we want to go, now there are several different ones. The ANSI inch, that's American National Standards Institute, inch or metric. Then we've got the British Standard, Australian Standard, Canadian, I believe this is the German maybe, or Dutch. Then we've got other various. Now ISO is the international standards. Then we've got the Japanese standard and a Korean standard. And then also the military spec. Mil spec is if you're a defense contractor and you need to use mil spec hardware. Then the PIM. PIM is used for a lot of automotive. Then we have SKF and Torrington, and those are some bearing manufacturers. True Arc, which is a retaining ring deal. And then we've got Unistrut, which is used to hold components in place. So we've got some different standards there, and I'm going to double click on the ANSI inch. And then within that, we've got catalogs for bearings, bolts and screws, jigs and bushings, keys, nuts, O-rings, pins, power transmission for gears and such, retaining rings, structural members, that's steel, and then washers. So right now what we need is pins, so we'll double click pins. And it says all pins, and it also moved to the pins up here. So we'll double click the all pins. And now we've got the different styles. We've got clevis pins, and if you hover over them, they'll pop out and you can see what they are. Dowel pins, hardened. Dowel pins, unhardened. Another dowel pin, just a general. And what we want to use on this is a spring pin slotted. So we can use that. Then we've got straight pins, and they're solid, and then tapered pins. But the spring pin slotted is a hollow pin, and it's made out of spring steel, and there's a groove cut in it so that it can squeeze down and conform to the hole, and then it will essentially spring back and make it one particular subject. So we'll drag that over, and we just placed one in the assembly. Now note here we've got different sizes. Okay, we know we need a half. And then note the arrow here. If we drag that arrow, it'll show the different lengths that we can get. So, and that's interactive, kind of a heads-up display. We know we need it to be 4 inches, so we'll accept that. And we're done with the insertion, so we'll just hit escape. So now we've got our pin in there. Well, the next thing with them would just be to go ahead and do some mates. So I want to mate this cylinder to the hole. Okay, and if we rotate that around, we'll see that they're lined up. So we accept that. So now that's moving up and down in the hole. Okay. Then we'll go in there, and the best thing to do now would be to pick this face here. If we can get to the face, and this face here, they'll be coincident. That means they've got the same flush face, if you will, and it's flush on the back because that piece was 4 inches. And we've just inserted a piece that was a stock part from another manufacturer. Now we've got one more of those situations, and that's down here. We need to put a nut on that so we can tighten that nut down and keep this guide in place. So we'll go back to our design library, and we said we needed nuts now, right? So we'll go to the nuts, and then it's a matter of, do we want an acorn nut? Do we want a hex flat? And again, if you double click on that, you can see what the acorn nut looks like. Okay, now I don't need that, so I'll go back up here. What I really need is just a hex nut. And then, of course, you've got the hex flat nuts. We've got hex slotted, which is sometimes called a castle nut. Machine screws, and note you've got a square nut there. You've got square nuts here, and then you've got T-nuts. So hex flat is just fine, and we've got hex flat jam, heavy hex flat nut, heavy flat or hex flat nut, flat jam nut, excuse me. So I don't remember exactly what the piece calls for, but we're just going to put a regular hex. Well, let's put a heavy hex flat jam nut on there. So we'll just drag it out. We just drag it out into the part. Okay, now what size was that? We'd had to figure out what this was, and I believe, if I remember correctly, that was a 5/8 diameter. So we'll need to go to 5/8. Oh, and it looks like we're not going to have any of those. So we'll have to hit escape, and we'll have to get out of there and do it again. Let's go with just a hex jam nut. Let's see if we can come up with the right size this time. Let's go over here and see what we got. We've got some bad components here. Let's see what we can figure out. What are we doing wrong? Let's just go with a flat nut and see what it says. We're in a range that's way too big. Yeah, that's just way too big. So let's see. Let's go to the hex nuts. I sure thought we just did a heavy hex jam nut, but let's pull it over there again and see what we get this time. There we go, that's better. We need a 5/8. Let's see, that was a 5/8 11, I believe. Now that's the only thing we need to know about that, so we click it, and we're good there. And I could keep placing instances of this, but I really don't need to, so I'll hit escape. And now it's just a matter of mating these up. And I might mate this face and that face. Accept it. And then I might get this cylinder and that cylinder and accept it. And that's really all I need on that. This can still turn. This should still, yeah, there we go. That turns. And then finally, I would probably want to hit the save button. I should have hit that sooner. And this should all be put together then at that point.